All right, so good afternoon. First of all, I would like to thank the organizing committee for having me here, Audrey, Bill, Tim, and Nicola as well. And also thanks to the UAE Pavilion who made this happen. So today I'm going to talk about the philosophy and the approach we are taking in solving the water problem. And the way we're going to do that is through nature. But first of all, let me go through some basics science that we all covered back in the day, but we conveniently forgot. The first thing is, this is Earth, and Earth is 71% water, but we call it Earth. Ironically, should we call it water instead? But here we go. It's a human-centric way to naming things. It's Earth, and we will go with that. So if we look at this 71% water, let's look at the breakdown of where this water is. So if we look at this breakdown, we know that most of the water are in the oceans. And obviously the oceans are not suitable for human uses or for irrigation of land-based agricultural or trees or plants and so on. So you basically remove 96.5% of the equation. You end up with fresh water that is trapped in glaciers, ice caps, groundwater, 31%, and then surface water and other freshwater resources. All right, so we depend on surface water, which usually civilization are basically concentrated around the surface water itself. So let's look at the surface water. Most of it is also trapped in ice and snow, a little bit in lakes, and the rest of it are in atmospheric water, rivers, swamps, and soil moisture. So in essence, most of the fresh water that we need to use is really a fraction of all the water available in the entire Earth itself. So the challenge for us is how can we sustain the growing economies around the world with the water source that we have. So let me go back to a basic natural water cycle. We have been using this natural water cycle throughout our life, but we really don't appreciate it that much. The key thing about water natural cycle is the evaporation. Evaporation is the constant that happens everywhere. Even in the North Pole, you have evaporation. A little bit, but still evaporation. What we depend on is the chances of condensation happening after you form the clouds. And condensation and precipitation of all the water that comes from the evaporation, which basically start the natural water cycle. The precipitation could be a snow, could be rain, and we wait for it. But we forget that evaporation is happening every day. So keep this in mind because that's a key part of why we are doing what we are doing. So just looking at the amount of water that evaporates from the oceans. About 470,000 million cubic meter of water evaporates every year. The amount is staggering. Obviously, we don't see it because it's always precipitated in the ocean. The one that I would like to focus on is the human part of this equation, how much we are using from all the water cycle itself. We use about 24,000 cubic meter of water per year, right? Obviously, for us, we take water from underground, we take water from the rivers, we wait for the ice to melt to give us lakes, and that's how we can use water in this process. So the question is how we can actually capitalize on this in a way that will allow us to sustain the growing population. So if we plot the growing population versus the water usage, we know that there is a direct correlation. We know that more human means that more water consumption will be there. So this picture tells us the population was 1.6 billion, and then it's going to be about 8 billion already. And the water usage is tracking that growth clearly and linearly. But if we take this down and we break it into the different industries, we notice that industry uses a little bit of water. Domestic use by human is less. But look at this. I know that most of you know that 70 to 80% of all water usage is for agricultural activities, whether it's for landscaping or farming or commercial farming activities. Most of the water that we produce will go to irrigate something. So keep that in mind. Now, obviously, we are at a point where we have to deal with the climate change as well. So the idea that we can sustain growing population at the same level, where we also have issues with the climate change that not only impact our comfort, but also impact our water resources. So we know that if we don't do anything, then we have to actually live with the fact that the Earth's temperature will increase to an unsustainable level. And it's already been touched upon that when it rains or it doesn't rain, it's really extreme. Either you have flooding or you have droughts because of the climate change. So now, the other issue with the climate change is the higher the temperature, the more ice caps will melt. And honestly, ice caps are very crucial because they are a storage of fresh water that we are losing. We actually visibly, we can see it, we lose this ice in the form of water that goes to the ocean, unfortunately. And obviously, the ocean is salty. We cannot actually take it back unless it goes through the natural water cycle. So the question is how we should approach this issue with the water scarcity. So about 11 years ago, I was watching National Geographic, and they were talking about how people survive the elements, especially the lack of water. And one of the clear ideas was the issues in water scarcity in Chile, where the way they collect or produce water is basically spreading a lot of sheets, waiting for the fog to come, and the fog will be condensed on these sheets, and it can be produced as a fresh water. So you can see that it's a lot of effort to just make sure that all of these fabrics are placed in the highest points in the mountain, so they can allow the fog to condense and then can drain down the channels, which was created by all people of these cities to allow them to actually produce fresh water. So the idea here is that they have also waited for the precipitation to come to them instead of doing something else to allow them to produce fresh water. So when I was looking at this issue, remember, one of the key things we always emphasize is the food, energy, water nexus. And the idea here is that water is central to both food, and in order for you to produce water, you have to have energy. So scientifically, that's correct. You always need energy to do something. But especially in our region, we always need energy to desalinate water, and then we can secure our food future. So if you just go back 200 years ago, when we don't have electricity, people have always concentrated or lived around water resources. So the question is, can we replicate such approach in a sustainable way, where the energy for us is not about the energy that is transferred all the time, it's about the generation of electricity, which is the cause of all the CO2 emission that we are actually dealing with now. So let's look at how we survive the elements here in the Gulf. We have oil, so we can generate electricity out of this oil. If I use electricity, then the best option for me is to do reverse osmosis. It's the most efficient way to maximize the amount of water I can produce. So this is a typical desalination plant. The one thing that you need to understand for desalination is that I take the water from the Gulf, I send it into a process, and I produce fresh water. So it goes back to the cities. But I also produce 1.5 the amount of fresh water in the form of brine. And I send the brine back to the ocean. So desalination as it is right now have two issues: the CO2 emission and the brine production, which in the long term, it's going to harm the aquatic life in the sea itself. So for me, I ask myself, how can we resolve this conundrum? In order to produce water, I have to use electricity. So I said, we actually don't have to use electricity. We can do something else. So the amount of brine and CO2 that you can produce from the desalination is really staggering. CO2 emission due to desalination is about 74 million per year, and you effectively produce more brine than fresh water. So the answer is actually in front of us. I said that water cycle always starts with evaporation. Rain, snow, and fog are actually the exception to the cycle. They happen infrequently, and they happen in different geographies. But evaporation always happens all the time. So let's look at the Arabian Gulf as a body of water of how much evaporation happens from the Arabian Gulf. Arabian Gulf evaporates 350 cubic kilometer of water per year. To put this in perspective, if you put all the desalination plants in the world, all of them, the one in Asia, in Africa, in the GCC, in the US, in South America, all of them produce 35 cubic kilometer of water per year. So you're talking about 100,000 desalination plants versus one water body that produces already 10 times the amount of water in single year. Now, the map tells us that we don't get much of this water back because the rain for us is really infrequent, and this water vapor goes somewhere else and precipitate to give rain in another location. So I asked myself, okay, if I know that evaporations happen, what shall I do? I can do the following. I can basically put a gigantic igloo on top of the water to produce fresh water, because when the water evaporates, it will be trapped in this gigantic dome, exactly and similar to this dome. You put it in the ocean and you produce fresh water. It's basically mimicking the natural water cycle. And actually, after we are done, if we can take this and put it in the Gulf right away, we can produce fresh water already. So we can talk about it, Tim, later on. And humans have already tried to do something big already back in the day. So it's not like something we cannot do as humans. If you recall, the Colossus of Rhodes was an example of us trying to, erect gigantic structures, either to satisfy an ego or to at least show it can be done. But the idea is actually really simpler. A few years ago, I was walking in the desert. I noticed that some people have thrown, unfortunately, a bottle of water. And this water bottle, you can see that it can actually condense fresh water inside it. So the concept is not really new. It's called solar still. But the idea, how can we commercialize it to allow us to produce the freshest water with no energy? So here's our concept. We try to basically mimic the natural water cycle, but in a small scale. I take this device, I put it on surface, water surface, allow the solar radiation to go inside, the water will evaporate and will condense to give me the purest water. This water that you produce here have no salt, no impurities, nothing. And in the process, I don't need to use electricity, I'm not producing brine, and I'm not emitting CO2. So you're solving the three issues in water desalination at once. The question then is, did it work? Actually, we tried it using different prototypes. So this prototype, we place it in an area in the Arabian Gulf to show that the concept can work. This device is in a small farm in Abu Dhabi. This pool is a brine pool. It's salty water. And we showed that the quality of water we produce, it's of the highest standard. So that's what we have been trying to do, and we are actually at this stage going to use this technology in a pilot project to grow crops, because even though we like to use this water, I told you already that 70 to 80% of all water uses in the world is for growing crops and for plants and so on. So this is our journey, and just at the end of this, I would like to emphasize how much area I need to cover to produce the water needed for UAE. For UAE, based on the current technology performance, I need to cover about 2,600 square kilometer of area, which is 3.1 of land area for UAE to satisfy the UAE requirements of water. The coverage doesn't have to be in the land, it can also be on the Gulf. So 3.1% is not a lot, frankly speaking. So we're trying to bring this technology as soon as we can to the market, and that's what we are going to do in the next phase. And we've been supported so far by many different entities in UAE, and we've been part, as Audrey mentioned, in different programs, and we won different awards. So these are the collaborators and people who we interacted with. And with this, I thank you so much for your attention. And if you have any questions, please let me know.